This is Team Samantha, and we are going to talk about bullying. Bullying is defined as the use of force, coercion, or threat to abuse, aggressively dominate, or intimidate another individual. And it must include hostile intent, imbalance or power, and repetition over a period of time in order for it to be defined as bullying. With regard to the topic, we particularly looked at bullying in Maryland public schools. Just in 2012, a 15-year-old Grace McComas, a Maryland high school student, died by suicide after being bullied and sexually harassed with little school assistance. And in 2013, Grace's law was enacted to make cyberbullying a criminal offense, therefore jailable and finable in the state of Maryland. And these are just examples of what has been done in order to prevent bullying, but it's still a problem. During a school year, schools reported that bullying incidents happen on school property, via internet, and on school buses or at activities of school properties. For 28% of the incidents, the motives are unknown, and most victims are between 8 and 15-year-old. These statistics led us to our objectives. So first, we wanted to find trends. Is there a correlation between race, special education, English learner status, school population, and bullying? Secondly, we wanted to create a model to determine the prevalence of bullying occurring in a school contingent on the demographics of the surrounding neighborhood. And thirdly, we wanted to address issues and spot anomalies. So with all those objectives in mind, our original data came from three different data sets from the Civil Rights Data Collection website. The three data sets were on bullying on the basis of sex, bullying on the basis of race, and the third one on the basis of disabilities. After much consideration, we decided to focus on bullying based on race. And because of the large size of the data, we changed the variables as a percentage of total enrollment, removed some formulas, added a categorical variable to classify the bullying rate from low to high. And after doing all that preparation, we were able to exponentially reduce the size of the data.
So for our data set, we used two versions of supervised learning to approach how we would tackle these problems that Mia discussed. The first was trying to do a linear regression through prediction to find out if there was a direct correlation and we could find coefficients that were quantified to the demographics that we inputted. We also tried to do classification of k-nearest neighbors, but we ran into some hiccups for that. For a data set, we were not able to run the traditional data set we had with XLMiner. It was interesting because there were 34 distinct values for bullying that we saw, and with those k-nearest neighbors, it was too much for XLMiner to handle in the free version that we had. So instead, we switched the categorical variables from quantitative to qualitative for being low, medium, and high bullying in schools. The way we categorize this is in both the data set that we had no bullying and we had bullying included, if it was under 0.3%, we called it low. If it was between 0.3% and 0.6% bullying, we called it medium. And if it was over 0.6% bullying, we called it high. So the first data set that we looked at was running a linear regression, including our non-reporting schools, which were the schools that had 0 cases of bullying reported in the 2015 school year. At first, it looked like this was a great correlation. We had a very small RMSE for both the trading and validation data. It was 0.0018 and 0.0011 respectively, which were very close. But we quickly realized that the data we were looking at was between 0.3% and 0.9% for the majority of the data. So the root mean square error would be skewed because we were looking at such small numbers. However, when we looked at the R-squareds, we realized this was a horrendous fit. it was an R squared of 0.0457 for training, and we actually had a negative R squared for the validation data, which was very shocking for us. So at this point, we realized that maybe running a linear regression, including having over 99% of our data have just zeros in it, would not be the best. So we decided to run the linear regression results excluding our non-reporting schools, which gave us slightly better data, but still was not usable data. We saw that with the prediction summary, our RMSE was a flat 0 and our R squared was 1, which got us very excited when we were looking at this data that we had a perfect data set for training. However, when we saw our validation, it was the exact opposite case. Our RMSE was closer to what we saw in the last metric of 0.0076. Our R squared was better. We were at 0.285, but this was still not at all a conclusive result, which led us to realize that linear regression would not be a great fit for predicting bullying metrics in Maryland schools for 2015, whether we included or excluded non-reporting schools. So next we decided to look at our k-nearest neighbors results, and we decided to go back to the full pure data, including non-reporting schools. And the results we had were astonishing. The confusion matrix showed that we had so many errors that our error reports were in around 70 to 80% for our training data, and in some cases were 100% for our validation data. We saw that this was really caused by the fact that there were so many schools that did not report, and it was trying to overfit for those cases, and they had less than 1% error in those cases and a very low error overall. But for schools that reported bullying, it was not a good fit. When we also looked at it, the KNN was all the way up to 9, so we knew that this data was just being completely thrown off by the fact that there were so many data points that were non-reporting. So when we then switched to doing a k-nearest neighbor excluding non-reporting schools, we at first were very excited when we saw our training data. We saw there were no cases of error reports, everything was fitting great. And then when we switched over to our validation data, we saw that we were overfitting again. Our confusion matrix and error report showed an overall error of 52.38%, so showing that more than half of our data, the 11 of the 21 cases, were giving us errors in our validation set, was just astonishing. And even if you're comparing the fact that one had no errors and the other had 52% errors, it averages to about 20% error report, considering the 60-40 split. And we realized that this was not a strong correlation as well. No matter what data set we tried to do, it wouldn't work in supervised, and we weren't able to do unsupervised due to the scope and range of our data and the fact that XLMiner couldn't handle this big data of a set. And this led to us having some very amazing conclusions that Sam is going to delve into now.
So as the data that Nima went through shows, the conclusions we came to are fairly complex. It's not an easy story and requires some interpretation. The first conclusion we came to is that non-reporting is a huge problem. And this came out because the errors that we were coming up with for all of the models where we used the non-reporting schools, the errors were so high as to be basically non-interpretable. And so that shows that schools need to do a much better job of boosting the reporting of bullying incidents, and only at that point are we really going to be able to do meaningful, robust analysis of the school and come to firm conclusions. The second conclusion we can make is that once the non-reporting schools were excluded, we were able to get some classification data that had some predictive power, as Nima said, with error rates in the 20% to 60% range. So this shows that once you get rid of those non-reporting schools, you can make some conclusions. Still not very powerful, though. I think what we can tell from there is that demographics are not actually as predictive as one might have thought from the beginning. So it doesn't disprove that demographics are really important, but it shows that they're not as predictive as we might have thought. And so maybe that's an interesting conclusion that we can make. So the implication we can draw from this is that schools really need to do a better job of boosting their reporting scores, and maybe other factors besides demographics can be looked at make conclusions about what's going on in bullying.